Hello friends, welcome to another lecture number 19 of electricity and magnetism. And our topic of discussion is potential and electric field of a dipole. And before we start, please subscribe the channel if you are new to my channel. Also share with your friends and help me to grow my channel. And also hit the bell icon so that you get notified when new video will be uploaded. Suppose potential and electric field due to a dipole. Suppose we have a dipole. This is a dipole. We have a dipole consisting charge minus q and plus q separated by a very small distance d, suppose, and this is a point P, and its position vector with respect to the origin B, suppose r. Let me take this r, and at a distance of r1 and r2 respectively from these two charges, minus q and plus q charges. Okay, so P is at a distance of r1 from q positive charge, and at a distance of r2 from q negative charge. So here it is this angle be suppose theta, and here this distance is d by 2, right? And the axis of this dipole is along suppose x-axis, right? So now you see, let me write what I have considered here. Okay, so these are the things that I have considered. Let me write here properly. Okay, now you see, and theta be the angle between x-axis and vector r, right? So hope you have understood this. Now let's go to the next slide, and before going to the next slide, let me copy this diagram, okay, because we're going to need this figure. So here is the diagram. So now the potential at P, what will be the potential at P? Now you see, potential at P due to this q positive charge that going to be given by 1 by 4 pi epsilon naught positive q charge by this r1. This is the potential due to the positive q charge, right? And potential due to the negative q charge will be this minus 1 by 4 pi epsilon naught q by r2, right? At P, right? So the net potential will be you can, if you take these two common, then the net potential you will get 4 pi epsilon naught 1 by 4 pi epsilon naught q by r1 minus q by r2. That's what you will get. So that will be the potential. So let me write it properly. Okay, so hope you have understood these things. So potential at P due to the dipole is given by, let me write here phi, which represents potential at position r, right? So here it will be 1 by 4 pi epsilon naught q by r1 minus q by r2. You can take the q common, right? So you can just let me keep it this way. Okay, so here you see, now you see, suppose you have a triangle. This is a triangle. This is suppose you see here, let me consider the sides. This is A, this is B, this is C, right? This is C, and here this is the angle theta. Suppose this angle is theta, right? Then according to the cosine rule, so if you apply cosine rule, then you should get A square is equal to B square plus C square minus twice BC theta, sorry, cos theta, right? Cos theta. So this is cosine rule. Now if you apply the same rule here, this side is r and this side is r1, this side is d by 2, and angle between these two sides is theta, then this r1 will be given by r1 square, that r1 square will be given by r square plus d by 2 square whole square minus 2 r d by 2 cos theta. That's what we should get. And then 2 will be cancelled, we will get rd cos theta, right? So let me write here cleanly. Here you can see, so we should get r1 square is equal to r square plus d by 2 whole square minus 2 d by 2 r cos theta. That's what we should get, right? So here you can see, so this is r square d square by 4, and here you will get dr cos theta, that's what you should get. So taking r square common, if you take r square common, then you will get 1 by r square plus d square by 4 r square. Sorry, here I have missed the minus here, minus sign, minus d, so r by r square, that's gonna be r as a denominator, right? R here d cos theta, that's what we're gonna get on taking r square common. So therefore r1 will be equal to here square root of r square will be r, right? So now you see, here we will get 1 by r square plus d square by 4 r square minus d cos theta by r whole to the power half. That's what we're going to get. So let me copy this last result and let me write on the next slide. So this is the result we have got so far. So now you see, if you take reciprocal, so 1 by r1, so let me write here in place, 1 by r1 will be equal to 1 by r, this power gonna be negative on taking reciprocal, so here 1 by r square plus d square by 4 r square, d square by 4 r square minus d cos theta by r whole to the power minus half. And if you expand this, then you should get 1 by r, then 1 plus d cos theta by twice r, d cos theta twice r, and plus in the remaining terms you will get you will get d square, d cube terms, those kind of terms, and we can neglect that because d is very small, right? So we can neglect those terms, right? If you expand this term, then we should get this result, right? So here you see, so 1 by r1 is approximately equal to 1 by r plus d cos theta by 2r square. Okay, so here we're gonna write, neglecting the term, in d square and higher order terms, and higher order terms, as d is very small, very small, right? So hope you understood this. Now you see, similarly you can find 1 by r2, right? Similarly you can find 1 by r2. So here you see, then we have to take this angle, that is pi minus theta. So here cos of pi minus theta, that's going to be minus cos theta. So that's why your result going to be 1 by r minus d cos theta by 2 r square, right? That's how we will get. So now we have got 1 by r1 and 1 by r2. Now let us use these values of r1 and r2 here in this result. So let me write this as equation number 1. So now using these two results, so let me consider this is suppose equation number 2 and this is suppose equation number 3, using 2 and 3 in 1. So let me write using 2 and 3 in 1. So what we have done, we have used this 1 by r1, value of 1 by r1, which is this one, right, in equation number 2, and this is the value of 1 by r2 in equation number 3. Let us use these two values in this equation number 1. Here q by r1 means q into 1 by r1. So here we're going to put the value of r1, 1 by r1, right? Similarly q into 1 by r2. So this term, so here we're going to put 1 by r2 value of 1 by r2. So now, so what we're going to get, so this is what we have got. So let me explain one more time. Here you see, so we have used this equation 2 and 3 in equation number 1. So we can take q common outside here, right? So and doing so, we're gonna get phi r is equal to q by 4 pi epsilon naught 1 by r1 plus 1 by, sorry, not plus, minus 1 by r2. That's what we're going to get. So here we have put 1 by r1 and 1 by r2 from equation number 2 and 3, and doing so we have got this result. So here you see, if you remove this bracket, then what you will get, this sign will be positive, and here 1 by minus 1 by r, and here it should be 1 by r only, not r1. That plus 1 by r gonna be cancelled, and that's why what we will get, q 4 pi epsilon naught 2 d, if you take LCM, 2r square will be the LCM, d cos theta plus d cos theta, that's going to be equal to 2d cos theta, and here d 2 cancels. So we have got that phi r is potential due to this dipole at P, that q by 4 pi epsilon naught d cos theta by r square. That's what we will get. This is the result, right? So now you see, we can express this in terms of dipole moment as well. So dipole moment is a vector quantity. So here you see, let me draw the diagram again on the next slide. Let me copy this result as well, what we have got. So here you see, so direction of dipole moment is always from negative to positive. So along this direction, this is the direction of dipole moment, right? So this is the direction of dipole moment. So here you see, so here this p vector is the dipole moment. Suppose dipole moment. So having magnitude, q into d, right? So because here charge is q and distance between them is d. So suppose this is a dipole, this is negative charge, this is positive charge, and if the distance between them is d, then the dipole moment, its magnitude is given by that charge into distance d, right? So hope you know distance. So now you see, here what will be the dot product of this vector p and this r vector. This is the position vector r of the point p, and here this is the direction of the dipole moment now, and angle between them is theta, then the p r vector p dot r, that will be p r cos theta, right? That will be p r cos theta. So p r cos theta. Now what we can do is the magnitude of p is this q into d, right? Q into d. Sorry. So let me write magnitude of p is q into d, right? So here you see in this expression, this q into d, that can be replaced by this small p, right? So this p is nothing but you can write q d. So here we have r cos theta, right? Into the r cos theta. So p d r cos theta, as we have got, so here we have q d cos theta, so we can write q d cos theta is equal to p dot r vector divided by r, right? So hope you have understood this. Now using this result in this equation, this is equation number suppose 4 and this is 5. Using 5 in 4, if you use this equation number 5 in 4, then you can write this result as, let me go to the next slide. Okay, then you can write 5r, that can be p dot r, p vector dot r by 4 pi epsilon naught r cube, because here you see we had phi r is equal to q d cos theta and by 4 pi epsilon naught r square, right? Then we have got that q d cos theta is equal to p vector dot r vector by r, right? Here you see in these two equations in 5 and 4, right? So we have got these two results. So here what we have done, we have used equation number 5, this equation number 5, and this was 4. Using 5 in 4, we have got this result, right? So here this thing is replaced by this result. So there was r square and multiplied by this r, so it becomes r cube, right? So hope you have understood this. So this is the potential of a dipole, right? So this thing is clear to you, I think, right? So now let us talk about electric field. Dipole moment is of the dipole is given by this 3 p vector dot r vector, then again r vector here by r square minus p vector. That is what we will get. So hope you have understood and hope you have enjoyed this video, and if you have enjoyed this video, please share with your friends and help me to grow my channel and inspire me to create new content for you. Thank you for watching. See you in the next video.